grades yesterday at night. I'm not sure if you guys did it, but I was having the sheets. I looked at the sheets. I believe that you guys deserve more points because he basically, if you didn't solve it correctly, he just like give 0 or something. So I'm gonna, yeah, his hand was a little bit heavy. It's the grades. I told him, everything I told him, just like be easy. And he said, yeah, I'm always easy. So that's easy. All right, so I'm gonna go through the sheets again. I'm gonna give it one more round of grading, so you might expect a little bit more points. So, but I'm not sure when I will get time to do that because it's a 70 students. So maybe by the end of this week or early next week, like on Tuesday next week, you might have. I'll try to give it sometime today, but we will see how far I can go. And that's one thing. The other thing is after I do the grading and you feel that you that you deserve more points because you did much more effort in this problem, or I didn't grade you with the way that you were expecting, you can come to my office. Everyone comes to my office, he walks out with points somehow. I'm not kidding, yeah. But you come and discuss it with me. Oh, I did this that way because I think that way was the right way. So you tell me your thought process. Why did you approach this problem that way? And we can have a conversation. And if you deserve more points, I would give it to you. Okay? So that's the second step. So once we are all settled with the grades and everyone gets the points that he is supposed to have, and I'm gonna do the curving. Because the thing is, this is how curving works. Let's say that I give you the sheet and I already curved the whole class. So you might end up having 85. But the thing is, many students came to my office and got more points, so the average went up a little bit. So when I do the recurving, you might get less points. So when other people get more points, the thing is the average goes up for them, so I have to bring the average a little bit down, so I don't want to disappoint you. Like you'll see, oh, I got 80, and then the next day you got 75, so you'll be disappointed, right? So we're gonna do it that way. Is that fair enough? Okay. All right. So okay. So I have one more update for you. So I'm not sure if you guys, I told you at the first of the semester that we have a fluid dynamics part. So this part I believe is 1 or 2 weeks, and I just talked to Dr. Arturo Ulloa. He said that he might have his lectures after the spring. The spring break is by the end of this month, right? So he might.
Spring break is next week.
Next week, right?
Yeah.
So there's no classes next week. So the week after, like in March, he can start his fluid dynamics classes, and I believe he take 2 lectures, maybe 3. I don't know. We'll see how long he's gonna take. And that's one thing. So maybe after the spring break, I will not he will be in class with you. And then maybe by the end of March, we're gonna have a visit to the Nihiri Wall of Wind, just one visit. And I would recommend that most of you attend this visit so that you guys see, like, it's one of the largest testing facilities in the US that test like full scale wind. Like if we, like when we design buildings or like tall buildings, any tall building designed, it requires wind tunnel testing. So seeing how this facility looked like and getting a chance to get inside there and know what's going on there, it's really good for you. And I believe right now Nihiri has opening for internships. I got the flyers. I'm not sure if you guys got the flyers or not. So that's also a really, really good opportunity if you want to be in the future a catastrophe modeler. Having an experience in Nihiri Wall of Wind is going to really, really help you. I'm not sure what branches that you guys are going to pick at some point in your career. Maybe some of you are going to be structural engineers, some of you are going to be environmental engineers. All these fields are really great. Infrastructure engineer, whatever field that you're going to pick is really great. But what I want to say is the field of catastrophe modeler is have a lot of demand right now. Like being a structural engineer, I was a structural engineer for 5 years after I graduated. I love it, and I designed a lot of tall buildings when I graduated, and I was really fascinated with what I have done. But I shifted after that to the catastrophe modeler. After 5 years, even that I got my master's in seismic and tall buildings design, But when I did my PhD in catastrophe modeler, I liked it much more what I have done before. And let's talk money. Catastrophe modeler get paid more than regular structural engineers. The most or the highest paying salaries in our field, we are all civil engineers, right? So the highest salary in civil engineering, it's either you are a forensics engineer or you are a catastrophe modeler. However, there's some companies that they pay high for structural engineers design, but as far as I knew from all of my friends that went outside and working even for the best companies in the US like Jacobs, Stantec, ACOM, all these companies, still they don't make as much as if you are working as a catastrophe modeler. And to be a catastrophe modeler, maybe your background, I mean like bachelor, maybe it's not enough. And you definitely need a master's to have some courses about like risk and reliability and natural hazards. You have to have more wind engineering background, maybe more hurricane, more flooding engineering background. But what I want to say is, even if you did masters, it's gonna pay off. Like if you want to be a catastrophe modeler, let's say, I'm not sure. Do you guys know what catastrophe modelers do? I keep saying catastrophe modeler, nobody's doing it. Okay. So do you guys know what civil engineers do? You guys are what year civil engineering is this? Like you guys are like second year?
I'm third.
So second, third, right? So do you guys know after you graduate what you were supposed to do?
You could do design, like highway design, road
Like-
design,
Okay, design what?
like structures.
What kind of structures?
You could do like skyscrapers,
Buildings, that's a structural engineer, that's a specialty. There's bridges, that's a complete different specialty. Infrastructure, like design the water system for a community, that's a complete specialty. Like the people who do, like if you go to a senior infrastructure engineer, he might not be able to design buildings, but he might have a little bit, remember the basics, but he's specialized in infrastructure. So maybe, I believe at the second or third year, you have to develop what you want to do for your future. Like, do you want to be a structural engineer? So you take more structural engineering classes, or you get in depth in a structural engineering. So that's things that you have to do right now. Like in my third year, I know what I want to do. I want to be a structural engineer. So that's, I believe, that's what you have to develop. Some people, some of you are gonna, oh, I want to be environmental engineer. I want to study how the salinity of the beaches are impacting the soil, and you want to be a geotechnical engineer. That's really a fascinating field, but you have to know what you want to do so that you can be more focused. And I believe if you have a goal, like if you have a goal, I want to be an infrastructure engineer, so you will be motivated to do good in a school. Because let's be honest, if you have a really good grades, you will end up really good companies. Maybe, I don't know, some of you say, oh, grades is not, doesn't matter. It matters the expertise that you get and the internship that you do, but grades shows how much hard work you are doing. Because the students with high grades, that means, oh, this students put a lot of effort, so I want to have this with me. It doesn't show maybe that you are smart, but it shows that you are putting effort, and that's what most of the companies do. Okay, so first is that you have to put a goal, like what do you want to be? I want to be a structural engineer. I want to, maybe it's vague a little bit, but try to make it a little bit, oh, I want to be a structural engineer, but I don't know, I want to do bridges, I want to do buildings, I want to do forensic, you don't know, but at least pick something. And if you have this something in front of you, you will put effort so that you can be a better engineer. So that's one thing. So what I want to say is, try to decide what you are going to do with your future. Try to talk to people in the field, try to talk to people in the industry. But from my experience, from what I see, people that work in forensic, and forensic is mostly the people that they go and do damage assessment for your building. Like let's say a hurricane hit Fort Myers, Hurricane Ian. And the people who go to Hurricane Ian and do the assessment so that they know how much the insurance companies they should pay for these people, that's forensic engineers. They go and do the assessment, and they provide plans for the people. Oh, if you want to bring this building back to 100% functionality, you have to replace this column, or you have to bring a new beam, or you have to do this. That's forensic engineers. So they're really good. they really get high salaries. Catastrophe modelers is the people who, like, let's say a hurricane is hitting a specific community, like Hurricane Ian or Hurricane Milton hit Tampa. So there's many people that they do different things. There's people that we call them coastal engineer, and that's also a part of civil engineering. It's an amazing field. Some people, they do amazing in this field. They use the weather information along with some background in fluid dynamics and hydrodynamics modeling, and use all these weather information to predict with this information about the hurricane, how much storm surge and waves we are expecting on the shoreline. By the way, civil engineers do this, predict this. They are all in NOAA and a lot of other people. They would do all these analysis so that they can predict, because you guys hear in the news, oh, we have a storm surge of 15 foot is coming from this hurricane. Civil engineers, we call them coastal engineers. They do this analysis, okay? So that's a coastal engineers tells you that there's a flood is coming 15 feet or 10 feet coming from this hurricane. That's a specialty. There's a specialty, another specialty, that they take these flood depths and we know how much this 15 foot of water is gonna expose our community, like expose the building, the infrastructure, how each building is gonna get out of this flooding. Like I know that this building is gonna get 2 feet or this building is gonna get 3 feet. So that's what's called exposure analysis. That's also a specialty of risk modelers. They do exposure analysis. But the thing is, let's think about it. Like let's say a hurricane is hitting a community, okay? And there is a 15 feet of storm surge that's coming to the shoreline. And you know what each building are gonna get from this 15 feet. Not all the buildings are gonna get 15 feet. That's at the shoreline, but when this water get inside, it depends on your elevation, right? So maybe you will be exposed to flooding. Like let's say you are gonna get flooded, but maybe you are not vulnerable to have damage. Like, okay, like you got 3 feet of flooding, but your building is elevated from the ground. So you got flooded, but there is no damage because your building is elevated from the ground, or you built a flood barrier around your building. So you did some mitigation to avoid flooding. That's what we call vulnerability. So you might be exposed, but not vulnerable because you take precautions to do that. So that's what catastrophe modelers do. They study the vulnerability of buildings, and based on this, they can provide damage estimates of these buildings. And the thing is, when it comes to insurance companies, like you all know that you pay premiums, right? Like you pay premiums for your car or flood insurance or homeowners insurance. All this is based on catastrophe modeling. So insurance, like you are a structural engineer or a civil engineer, you can work for insurance company because they need catastrophe modelers to tell them what is the probability of having a specific level of damage with all these climate change for this building in the next 100 years or in the next 30 years. To study all these probability, they need civil engineers to do this. Like think about it, like how insurance companies are calculating that my flood insurance should be $1,000 a month. Just giving an example. How do you do this? First, they need to study the probability of the hazards to happen. So that's one thing. And if this hazard happened, how I'm exposed to this hazard? So buildings that are on a higher elevation are low risk, right? So you're expecting to pay less insurance. Or maybe you will not need insurance because you are elevated, so you will not even care about getting insurance. But if your building is low, you are more exposed, and once you are more exposed, you are gonna pay more insurance because you are having a high probability to getting flooded, so I will not risk insure you if you are gonna get flood next year and I'm gonna pay you $100,000 to recover. So that's on one second level, but let's say that you are exposed, so if I got flooded, how much damage I'm gonna have? Definitely, if I'm living in a luxury building, I'm gonna have a lot of things that are gonna get damaged, and all this is gonna be included in it. So yeah, that's what catastrophe modelers do. They study the vulnerability of the built environment, and I believe if you have this background, not only insurance companies, if you wanna work, like right now in my research, I work with the Broward County Office of Emergency Management, Miami-Dade County Office of Emergency Management, you might have a position there to be a state, even you can work for the feds, National Institutes of Standards, NOAA, FEMA, they all have catastrophe modelers. So yeah, just think about it. So yeah, what I wanna say is maybe you go to the wall of wind, that's your first step to know about how we model catastrophe. Wall of wind is a little bit at the building level, but we do, when we do research, sometimes we do it at the community level to study how the whole community is going to be impacted. And we say, when we say community, we say buildings, infrastructure, population, socioeconomic systems, all these making, comprising the community. All right, so that was a long introduction, but I felt like I have to tell you this so that maybe nobody told you this before. I'm not sure, but you have to know what you want to do from now, because 1 year from now you will graduate, so it's better to have a plan. Okay, let's get to dynamics. So I believe I'm almost done with the work and energy. I only have one topic to cover. Next Thursday, we are gonna have a quiz on work and energy, and I think maybe this will be our last quiz. So try to start the work and energy part so that you can do great in the quiz. You guys want it on Thursday? I can make it on Friday if you want to access it anytime. So which one that works better for you? Friday? Okay, I'm gonna open it at Friday, and you can access the quiz anytime you want, and it's gonna be on the work and energy part. Not this lecture. The lectures over the last 2 weeks. So we covered how the conservation of work and the conservation of energy and the principle of work and energy. So all this concept. Okay, so this is the last.
You said next week?
No, this week.
Oh,
By the end of this week.
Oh.
Next week is summer.
Oh, yeah.
Spring break. Yeah.
Yeah.
Okay, so you guys want it after the spring break?
No.
You wanna? All right. So power and efficiency. So you guys definitely heard about the term power. Like you always hear about, oh, this machine is 100 watts or 500 watts. So we always hear this term. But what is the term power? Power is the time rate of change of work. So power, the time rate of change of work. What that mean? So power B, if we have the work is W, so it's the dW dt. That's the time rate of a change of work. But do you guys remember what work is equal to? No, I mean like as a function. What is what multiplied by what? Force times displacement. So it was something like this: force vector multiplied by the dr vector, or the integration between them. Like it was kind of an integration between these like. Dr vector. Like if you guys you remember, it was something like this, and it was the integration of f dr from R1 to R2. If you integrate it, it's gonna be something like this. So that's the work. So if we put this here, so it's gonna be d. Oh, that's the d work actually. Okay, let me put it that way. All right, let me. So work was something like this. It was the integration of f vector, dr vector from R1 to R2. Why we put it that way? Because maybe the force is changing and the direction is changing. So we put them under the integration. But if they are all constant, we can take all of them out. If you guys remember, it was something f s cosine theta. They are all constant. But since this is the total work, what I'm looking for right now, not the total work, just a little bit of the work, the d work. The d work is is just this part. F vector, dr vector. And when you integrate both sides, it's gonna give you the work, right? So d work is equal to f dr. So I can put this here, f vector, dr vector, and I have here dt. And if I put f vector alone and I put dr vector dt, do you guys know what is dr dt is? The time rate of change of the position.
Velocity.
The velocity, right? So this is equal to f vector multiplied by d vector. So power is the force multiplied by the velocity. So if you have a body and this body is like this, and there's a force here, F equal 10 Newton, and this body is moving with a velocity 3 meters per second. So if you multiply 10 by 3, it's gonna give you the power that this body has. So always remember, power is force multiplied by velocity. Don't forget this. Okay, so that's the first thing that we have today. Let's talk about units. Do you guys know what units that we use to measure power? I just told you one a few minutes ago. Watts, right? Okay, so we have here the SI unit. Let me write it here. The SI unit. Right, if the force is in Newton, and let's say here, it's work over time. And if you guys remember the work over time, the work was Newton meter, and the time is second. So you can use Newton meter over second. Or if you guys remember, Newton meter was joule over second. So this is one unit that we can use to measure the power. How about the American unit, the US unit? The US unit, Newton, we use pound. Well, let's put feet, pound. So meter is gonna be feet, Newton is gonna be pound, and second is gonna be second. So that's also feet, pound, second. So that you can use it. And in the US unit, sometimes you use horsepower. HP. HP means horsepower, and this is another form of units that we use to measure the power. So it says that 550 feet pound over second is equal to 1 horsepower. So maybe I give you a question, and after you finish, I ask you to find the power in horsepower. So once you get it in feet, pound per second, divide over 550 so you can know how many horsepower this machine is, okay? All right, and by the way, the joule over second, we call it what? So joule over second, like the same way that we name Newton meter joule, we name joule over second was what? And what is a SI unit? And the US unit is feet pound over second, and sometimes we use horsepower, and 1 horsepower equal to 550. And also 1 horsepower is equal to, if we want to convert to the SI units, is going to be 745.7 meter Newton over second. That's equal to 1 horsepower. You can do actually this conversion, like you can convert the feet to meter and the pound to Newton, and you will find that this conversion is valid. So try to have this conversion maybe in your equation sheet, try to memorize it, whatever works for you. All right, so that's the first thing that we need to talk about it. So we finished the power, let's talk about the efficiency. All right, so efficiency, we call it EM. EM is equal to the power out over the power in. What does that mean? So let's say that you have a machine, okay? A winch or I don't know, any machine like a vacuum or any machine, okay? This machine takes electricity, that's power in, okay? But what it gives me out, that's called power out, Okay, so you put a power, and usually I'm only concerned in my problem with the output power when I study mechanics. Like, let's say I have like a machine, and this machine is like holding a weight. Okay, so what I can see is the output. I can see the input because the input is coming from the electricity. Like, I converted electrical energy to mechanical energy. What we are studying right now is mechanics. So I'm seeing the mechanics. So I'm always giving you the in power, but maybe I will not give you the output power. So you have to do some mechanics analysis or dynamics analysis to find what is the power out, and you can find the power out from here by multiplying the force by the velocity. Okay. All right. So let me ask you, what to expect of this value? What is the maximum value that you can get for the efficiency? 100%, right? What if you're solving a question and you find the efficiency is more than 100%? There's only two possible scenarios that can make this like more than one. Well, there's no way that you are gonna get efficiency more than 100%. You either did a mathematical error, so you have to go back check. Second, you are either like are gonna be a millionaire. You discovered something that is gonna make the efficiency like more than 100%. So companies are gonna fight to have you. Okay. So, and definitely this is not gonna happen. It's always less than 100%. Okay, so that's one thing. If you get the efficiency while solving the problems more than one, so that means that you definitely have a mathematical error. Okay, so let's solve a question. All right. Right, this example says that I have winch here and there's a log here and there's a wire goes all the way here, and there's like a frictionless pulley at this location that this wire goes to. And I'm telling you that this log a winch pulls 800 pounds, so I have the weight of the log is 800 pounds. Up to 30-degree slope, so this is slope at 30 degrees. With a constant speed, and be careful with the constant, so we have V is equal to 4 feet per second. And it's constant. This V equal to 4 feet per second. Using 6 horsepower output. So the horsepower output P out is 6 horsepower. I'm asking you, what is the mu K? Number one, what is mu K? What is mu K? The friction of the surface that this boat is moving on. And number two, if the power delivered to the motor, like this motor has like a power outlet here, and there's power delivered, so that means power in that goes into this motor is 3,740 feet-pounds per second. So power in is 3,740 feet-pounds per second. What is the EM of the motor? What is the efficiency? Let's find out. Okay, so this problem will definitely make like a free body diagram so that I can be able to solve it. So let's see what force is acting on this load. All right, so I have this load is something like this. All right, and it's moving on an inclined surface. This surface is 30 degrees. So can you guys tell me what forces are acting on this load?
Normal force.
Okay, normal force from the surface to the body. So my body have always a normal force like this. M. What is the second force?
The weight.
The weight, excellent. If I have weight here, it's always going to the gravity W. What else?
The tension.
Tension coming from the motor. So what is the direction of this tension? This way. So I have a wire here pulling this with tension T. What else? Friction. So what is the direction of the friction? Down, right? Because this is going up, so the friction is always in the opposite direction of the motion. So I have F of friction that way. Alright? Okay, so this is all the forces acting on this body. If I want to put the kinetic diagram for this body, so I'm going to assume that this is the x direction. And this is the y direction. Alright, so let's use the information that we have about the power first. So I give you the power in 3740, and I give you the power out that comes out of this machine is 6 horsepower. What do you think? Which one I will use in the dynamic analysis of this body? Is the power in or the power out? The power out, right? Because I don't care whatever electrical power that you give to this machine. All what I care about how much output power that come out of this machine so that I can pull this body. So there's lots of losses that happen inside this machine I don't care about. I only care about the output power. Okay. So right now I give you, let's write here that we are going to talk about power. So the power P, we always know that power P is equal to the force multiplied by the velocity. So it's equal to F multiplied by the velocity V. Okay, so I give you here that this body is moving with a constant velocity 4 feet per second. So I already know V. And the force acting on this, by the way, when I say the force, what do you think this force is equal to? The only tension that comes, because the power is based on this motor, and this motor is connected to this cable. I don't care about the weight, I don't care about the friction, it's the power is coming out to pull this log with a specific force. So the power is connected with the tension in this cable. So I can say that the power P out is equal to the force, which is the tension inside the cable here, multiplied by the velocity, which is 4 feet per second. And this is equal to 6 horsepower. And I told you what is 6 horsepower is. It's a 550 foot-pound per second. So I can actually, from this equation, I can get that the tension is equal to 6 multiplied by 550 over 4. And this is going to give you tension equal to 825 pounds. So I didn't ask you to get the tension, I asked you to find the mu k, but I will not be able to solve the problem because I have a known force here T, because I know the weight and I can somehow know the normal force, but I need other unknowns so that I can know the F of friction so I can get mu k. Alright. Okay, so I use the power. So you might use multiple concepts in the problem. Like, it doesn't mean that I give you power that is going to be a pure power problem. So that means maybe you will use Newtonian kinetics, or use work and energy. Okay? So since this is like, I see all forces, so I can actually use the Newton second law. Like I can say, right now, I can get the forces, summation of the forces in the y direction is equal to MAY. I do the same thing by getting the summation of the forces in the x direction equal MAX. This body is gonna move only in x direction. So what is the acceleration in y direction? 0, because this body is gonna move only this way, and I assume x direction is that way. So there's no chance that this body is gonna move in the y direction. So I can say that this is equal to 0. What are the forces in the y direction? The weight, but it's a component of the weight, right? This angle is 30 degrees. So I have n is positive minus w cosine 30 is going to be equal to 0. So the n is going to be equal to 800 cosine 30, and this is going to be equal to 692.82 pounds. Okay, I got the normal force from Fy. Let's find mx. What forces that I have in x direction? Okay, that's one. What is next? Friction. Tension. 3 forces. Which one is positive? Tension is positive. Minus F friction. Minus W. Cosine. Oh, sine. W sine 30 is going to be equal to MAX. You tell me, what is the value of AX?
0.
Why?
The velocity.
Excellent, because I told you that the velocity is constant. So since the velocity is constant, so the acceleration is 0, because the derivative of any constant. But if I give you the velocity is equal to 5t plus 1, so that means that the velocity is variable and you have to differentiate it. So let's say I give you the velocity v equal to 5t plus 1. What is the acceleration going to be? 5, right? You have to differentiate, so you are going to have acceleration. But right now, I told you that the acceleration, the velocity is constant, so the acceleration is also 0. Okay, so right now, I can write this. The tension, I already got it, 825 minus F of friction. F of friction is mu k multiplied by n. I already got n is equal to 692.82 minus W, which is 800 sine 30. And all this is equal to 0. So if I have this, I can get that mu k is equal to 0.61. Right? So first I use the power information to get the tension, and then I use Newtonian kinetics to get the sum of the forces in the y and sum of the forces in the x, and then get mu k. That's the first question. I got number 1. Number 2 is very easy. Number 2, I asked you to get the efficiency. Can you guys tell me what is the efficiency? It's V out over V in. So what are the values of both? V out is, I think, 6 horsepower. So this is 6 multiplied by 550, right? What is the V in? 3,740. So if I divide both of them, you are going to get 88.2%, or you can write it 0.88. That means that this motor has an efficiency of 88%. Okay? All right. So right now we are done with the chapter 14, and now we are going to start with the chapter 15. Does anybody have any questions so far? Is the concept hard? I believe the only new thing is the power is equal to F multiplied by V. So it's gonna be maybe a work and energy problem. It's gonna be a Newtonian kinetics problem, and I just give you a power so that you can solve one equation to get one force. And other than that, you are gonna continue with the same sentence. Does anybody have any question? This is 0.61. All right. Chapter between one impulse and momentum. Alright, so before I start this chapter, I want to tell you something. The way that we look at the bodies, at the movement of the bodies, we can look them at different ways. Like sometimes, if you remember in chapter 12, we only were concerned about what is the velocity of the body, what is the acceleration of the body, right? About just the movement. Then we start to be concerned about the forces, like, oh, this body has the weight and has friction and has normal force, so all these combinations, I'm concerned about them. And then we solved a lot of problems using the concept of forces, like this one, summation Fy, summation Fx. And then you can solve actually the same problem using the energy. Like I can solve this same problem using the energy concept, like the total energy at position 1 is equal to the total energy at position 2. That's one way to solve the problems. And sometimes we look at the problems from the eye of the impulse and momentum. How does that mean? So let me first see what is impulse and momentum first, and then we are gonna talk about how we are gonna solve problem using. So the old, if you guys remember, when we drive the work and energy, we drove them from this equation. Summation of the forces is equal to ma. That's how we drove the work and energy problems. And then what happens is, when we did work and energy, if you guys remember, we put that the A ds is equal to, do you guys remember? V dv, right? That's what we did. We put them here and we said that A is equal to V dv ds, and then we put that here, and when we put that here, everything starts to be function in S and V. And that makes sense when you solve a problem that you are given distances and velocities, and you are not given time. If you guys remember, the work and energy was something like this. T1 plus the work from 1 to 2 is equal to T2. So that was half mv1 squared plus a lot of stuff here like F multiplied by S, and here half mv2 squared. There is no time. But let's say a question I give you time, so there is no way that I can use the work and energy. I have to use something else. So rather than, I'm gonna put A equal V dv ds, and impulse and momentum, I did this to solve the work and energy. Work and energy problem. A also is equal to dv dt, right? So rather than I put in something as a function in ds, I'm gonna put something function in dt in time, and this is for impulse and momentum. So let's put that here. So we can say that the sum of the forces are equal to the mass multiplied by dv dt. So basically, if I somehow, this is also is equal to d dt of mv. Basically, if you take the time rate of change of the mass doesn't change. So the dm dt is going to be equal to m. If something is not changing, any derivative with respect to it is going to be the same. It's going to be the same thing. So m is going to stay, and then you are going to end up with dv dt. So this is going to be equal to this. So, and actually that's another definition of the force. Force is the time rate of change. Do you guys know what is this quantity is, mv? It's called momentum. So the force is equal to the time rate of change of the momentum. All right? So force is the mass multiplied by the acceleration, or it is the time rate of change of the momentum. So let's just start with this. So we have the sum of the forces on a body is equal to the time rate of change of the momentum. This is the same like this one, but we just put it in terms of the. And if I put dt here, so I end up with having that the sum of the forces dt is equal to dmv, and then I integrate both sides Since I have T here, I have to put here T1 and T2. And since I have V here, I have to put V1 and V2. So if I did this integration, I'm gonna get something like this. So the integration from T1 to T2 of sum of the forces multiplied by dt is going to be equal to the integration from V1 to V2 dmv. The mass is not a changing, so basically I can take the mass out of the out of the differentiation, so I can say this is m dv. Like the same way that I have it here. I basically put dt here, and I have mdv, and I integrate both sides. So if you did this integration, you are going to end up with, can you guys integrate this? When you integrate dv, it's going to be v, right? And when you put the boundary of the integration, so you are going to end up with mv2 minus mv1, all right? So that's the final output from the integration. So we call this part linear impulse. And we call this part that change in the linear momentum. So basically, this equation is telling us that the resultant force on a particle is equal to the time rate of exchange in the linear momentum. That's what we did here. And from this, we say that the linear impulse is equal to the change in linear momentum. So let's define what is impulse is and what is momentum is so that this can stuck in our head and we never forget it. So when we say impulse, it's like this. This is my body, and I'm gonna apply a force on this body and with a contact time t, or I'm gonna make this force on my body for a time t. If you multiply the force by t, that's called impulse. Okay, so force by time is impulse. Okay, we call it linear impulse. Okay, how about the momentum? The momentum is the mass of this body multiplied by its velocity. The same way that we say force is mass by acceleration, there's another quantity, it's called momentum, and it's mass multiplied by the velocity. Okay? So if this body has a velocity v1 here, and then at some point got v2, so the change between the momentum at position 1, mv1, and mv2 is going to equal to the amount of force that was applied on this body multiplied by time t. Okay? Alright? So if I have my bodies here, and I applied force F from time t1 to time t2, the change of the momentum between 1 and 2 is equal to F multiplied by t. Alright? Okay, so let's solve an example and see how this concept works. So I have an inclined surface like this at angle 30 degrees. And this body has a pulley connected here. And there's a cord and there's a force P here. I get you that the mu coefficient is equal to 0.3 for the surface, and I gave you that this body is moving with an initial velocity v naught is equal to 3 feet per second. So I told you that a 50-pound block, so the weight is equal to 50 pounds. This block is 50 pounds. Moves down a slope at v naught is equal to 3 feet per second and is resisted by kinetic friction uk equal to 0.3. Attention equal to b equal 10 multiplied by t, 10t. So the tension inside this cord is function in time, okay? Is equal to 10t, where t is the time in seconds, and this force was added for 2 seconds. So I applied a force P equal to 10 multiplied by t for 2 seconds on this body. So what I'm asking for in this problem, I want you to find the final velocity after 2 seconds of this body. This body started with 3 feet per second. If you apply this force, 10t, for 2 seconds, what is the final velocity? Okay, so since I have in this problem, I have v, and I have b, and I have time. So I have all, and I have initial velocity, but I don't have a final velocity. But I have a force applying for time t, so I have the left side of the equation. The right-hand side, I know the mass multiplied by v1, so only what I want to know is mv2. Okay, so let's find out. First, before I solve this problem, I want to draw the free body diagram. So I know all the forces that are acting on this body. All right, let me put this body here. By the way, the force is a little bit tricky. Let's see if you guys are gonna get it. What force is acting on this body? Normal force. Okay, I have normal force. Let's say normal force. Okay, what else? Weight. Alright, I have weight going down like this. Friction. So this body's moving down, so definitely the friction is something like this. What else?
The tension.
This thing, how much?
Is it
2B, excellent. Why?
2 cords?
Because I have 2 cords. Even if you have, that's actually the reason why we use pulley. We use pulley to double the force. So if you put B with another cord, you are making the B 2 B's. That's what we did here. So I have 2B here. So that's all the forces acting on this body. And let's assume X direction. By the way, the body's moving down, but I'm gonna assume the X direction going that way. And the Y direction moving that way. However, maybe it's better to assume the other one, but I did it, this is how I did it here. So let's stick with it. Either are okay. All right, so let's solve this problem. So the thing is, you can apply the concept of impulse and momentum in both directions. The same way that we did with some Fy and some Fx, we can apply this concept, the linear momentum, with the same way that we are doing the forces. How? Like I can say for X direction, like this is the equation. The integration of the summation of the forces dt is equal to mv1 minus, mv2 minus mv1. So I can say, maybe let's start with y direction. I can say that the integration of the force in the y direction dt is equal to mv2 in the y direction minus mv1 in the y direction, and then solve this one, and then I'm gonna do the same thing in the x direction. The integration of the forces in the x dt is equal to mv2 in the x direction minus mv1 in the x direction. Like the same way that we solved the Newtonian kinetics. Okay, let's see what we have in y direction. What forces do I have in y direction? By the way, the angle is 50 degrees, so this angle is 30 degrees. What is positive? Normal force and minus weight cosine 30. That's the force Fy, and we have dt here, and I have the integration. What is the boundary of the integration? This is dt, so the boundaries should be time, and it's from 0 to what? 2 seconds. Excellent. So, and then I have mv2 minus mv1. Can you guys tell me what is the velocity of this body in the y direction and when it's here and after 2 seconds? It doesn't have any velocity in y direction, right? It only moves in the x direction. So both of them are equal to 0. So I have all this is 0. So basically, I don't have actually to do this integration because I have these two forces. It's not function in time. And if I integrate them, it's gonna be, I'm gonna have a t outside. And if I divide over t, it's gonna be gone. So basically, I can say, you can actually do it. You say that n minus w is equal to 50, n minus 50 cosine 30, and when you integrate this, it's going to be multiplied by t, and the boundary is going to be 0 to 2 is equal to 0. So basically, you are going to have 2 of this is equal to 0. That means that this is equal to 0, and n is going to be equal to 50 cosine 30, and this is going to be equal to 43.3 pounds. That makes sense. By the way, you are going to get the same answer if you solve it using Newtonian kinetics. Like if you said summation of Fy is equal to 0, is equal to MAy, and AY is equal to 0, so you will find n minus 50 cosine 30 is going to be the same thing. So you can solve it either way. But if I told you in the exam, use the concept of impulse and momentum, so you have to do it that way. All right, let's do this part. What forces that we have in the x direction?
Negative 2p.
Negative. What is positive?
Friction.
The friction. So I'm gonna put F of friction first. And then what is next? Minus 2b minus w sine 30. And this is gonna be equal to mv2, which is what I'm looking for, minus mv1. What is v1? v1, I told you that this body started at v naught in this direction with 3 feet per second. And by the way, this 3 is negative because my positive is going over there. So I'm gonna put this as negative 3. That's why I told you maybe it's better to put it positive. But if I put it that way, so I have to stick with the whole problem. And actually, you can multiply by negative. So multiply by negative here, so the whole thing is gonna be okay. All right, so let's put numbers. So I'm gonna have F of friction, which is the normal force, which I just got. It's a 43.3 multiplied by mu k, and I give you mu k is equal to 0.3, and minus w, which is 50 pounds sine 30, and oh sorry, I have to have the integration here, right? And all this is dt. So, and minus 2b is 10t, so I have minus 20t. And all this integrated from 0 to 2 seconds. And this is equal to m, the mass is going to be 50 over 32.2 multiplied by the velocity f2x. And this is minus 50 over 32.2 multiplied by v1, and v1 is equal to negative 3. All right, I have to do this integration. So can you guys integrate 20t? 10t squared. And when you find this value, is gonna be equal to negative 12.01. And when you integrate this value, you are gonna have t here because this is constant. and this one is gonna be equal to negative 10t squared, and the boundary of the integration from 0 to 2. And this is gonna be equal to 50, 32.2 v2 minus minus is gonna be plus 3. So once you put the boundaries of the integration, basically if you put 0, this whole thing is gonna be 0. Then you are gonna put 2, and you will find out that the V2 is gonna be equal to negative 44.3 feet per second. That makes sense because all this positive and all this negative, so that's the final velocity. So, is that velocity direction make sense to you to be negative? Or is not? Make sense, right? Because all the forces are going down. I have the weight is going down and I'm pulling, so I assume that x is going up, so definitely the velocity is going down and the negative makes sense to me. That's why if you assume that in the other direction, so you are going to get V2 is equal to
positive.
I'm going to give an introduction about linear impulse. Alright, the equation that we started with, we said that the summation of the forces F dt integrated from t node or t1, the initial movement to t2, is going to be equal to m v2 minus m v1. We can write this actually, we can send m v1 to the other side, and I can say that m v1 plus the integration from T1 to T2 equal to the summation of the forces, the integration of the summation, the linear impulse, and here I can have V2. There is an interesting application of the linear impulse and momentum, and this application is when you have a collision. When there is an accident and two bodies hit each other, or you have two ball and then two of them are hitting each other. So linear impulse and momentum is really good application for that. So let's think about this. If you have a ball, let's say let's say this is a ball, and this ball is moving with v in this direction, and when you get mv1, it's going to be something like this, something that's moving that way, right? Then at some point, you apply a force or an impulse in the other direction, like in a different direction. Let's say that this is the force that you applied, and you applied this force for a time t, and this is the integration of f dt, all right? This ball, what is going to happen to it? Like a body's moving that way, and you put a force in a different direction. Well, it's going to move in a different direction. Maybe not in this direction, or not in this direction, completely different direction, because it's going to be the combination of both of them. It depends on how much you are gonna apply here to change the direction and the quantity of the movement here. So let's say the final is gonna be something like this, mv2. So that's actually the concept of linear momentum. It says that the initial momentum of a particle at time t1 plus the impulses applied to this particle from t1 to t2, like, is equal to the final momentum on this body. You have a body is moving with a specific amount of momentum. Let's say the momentum is this, and then you put a force on this for a specific amount of time, and this body is gonna have different momentum. This final momentum is equal to the initial momentum plus the impulses applied on this body. Okay. All right. So, and we did this like in a Cartesian way, like in x and y direction. Like we can write it the same way, and we can say, like we can convert this to mvx and mvy, 1, 1, and this one is the same thing. We can convert it to mvx2 and mvy2. And the same thing with the force. You can put the force, the integration of fx dt, and the integration of fy dt. All right? And you can say that all the impulses and momentum in x direction, and you can do the same thing for y direction. Like you can put it that way. Like x is gonna be like this. That m dx1 plus the integration of fx dt from t1 to t2 is going to be equal to mvx2, and y is going to be mvy1 plus the integration from t1 to t2 fy dt is equal to mvy2. Alright? That's actually the same concept that we apply here, not different. Okay? So let's see how this concept look like when we solve problems. Oh, we don't have time for problems, maybe next time. All right, so I believe I covered a good portion of the impulse and momentum. Next time, I believe we are gonna finish the whole concept, and we talk about impact when two bodies are gonna collide and make collision. And for now, I uploaded a new homework yesterday. I'm not sure if you guys see it or not. So I give you until after the spring break to submit it. That's one thing. We have a quiz. I'm gonna open the quiz on Friday, so you guys can solve the quiz. And see you guys on Thursday.